Good day to all. Today we are going to work on two different problems, and these problems are very simple, and it will be a good foundation to understand the upcoming mass and energy balance problems. So as a first step, we need to understand how to approach the problems. And mostly while working on any practical question, I determine which steps will be taken. So to solve this type of problems, we generally start with determining some steps. And by the way, I have taken these questions to solve for lesson 3 from any different internet source, and I don't remember it. But actually, these two main questions will be the main discussion for today. So let's start with determining the steps. I'll also show you again these questions. Let's go to the page. As I mentioned, we generally start with determining some steps. When I look at the question, I am starting with choosing some basis. What does it mean, basis? So this basis is selected regarding the problem. So if in the question said like to find it with mass, it means my basis will be mass. So next, if it's asked to find it with moles, it will be molar, or it can also be asked to find with volume. So the first step is ready. So you are choosing your basis. In the first step also, while you are choosing the basis, it's also very important to think about how much on mass or moles you can choose. For example, it can be 1 kilogram, it can be 100 moles, it can be just 1 mole, or etc. So that depends on you. And also the second one, the unit. After selection of the basis, you'll go to deep dive into selection of the unit. So if it's mass, most probably you know that from your high school, this is kilogram or gram. Or also this is SI units, yes. We have also CGF units. It will be pound, for example. If it's moles, it can be mole or kilomole itself. If it's volume, it can be meter cube, liter, or milliliter, and etc. So the third step, after being prepared with these two steps, the third step is beginning to solve the problem. So from your theoretical knowledge, what does it mean? So if in the questions, like it's given in mass, but it's asked you to convert it into moles, it means I need to do some change from mass to mole, or it can be vice versa, like mole to mass. How to do that? So we'll use some equations like molecular weight, it's equal to mass over moles. The main units we can see with molecular weight, it can be kilogram per kilomole. It can be gram per mole or something. This is the golden rule for starting. I believe we are ready to solve the question. So let's go to the Excel. By the way, I have completed these questions beforehand, the first and second, and it's ready like solution. I have just done it by myself to check the answers. Now we'll solve it together. It's highly recommended to work on the Excel because we need to do some calculations, and Excel will give us detailed analysis, detailed values. And drawing a table for mass balance assignments, it's also very helpful. So let's start with drawing some table. So our mixture of gases has the following composition by mole. It means my basis, the first step, will be mole. And how much moles will I choose? For example, it can be 100. Let's begin first of all gas. This is O2, CO2, and nitrogen. Now let's choose our basis. As I said, it will be mole, and I choose 100. The units are also completed. Next, let's define what is the molecular weight. The molecular weight is calculated like gas, it's equal to atomic weight multiplied by the number of atoms, and it will be 12.32, then it will be 14 multiplied by 2. Okay, next, let's go to the mole percentage. This is composition. Compositions are given 11, then 6, then 8, 3%. This is percentage, but if it's like fractional, it will be 0.11, 0.06, 0.83. Next, I need to determine what is the mole itself. So how to do that? It's equal to the total amount of moles, which is 100 in my case. It won't be changed. Multiply by 11% percentage and over 100. Okay, why I have done it? Because it should be fractional conversion. So the oxygen is ready. It's correct, yes. 100 multiplied by 0.11, it will be 11. And that's also correct. So I have also added here the sum, because summation will be very important in my case. The moles, sum again. It's 100 and it should be also 100. So this is correct. My basis is correct. My calculations are correct. Now, it states that what are the mass compositions percentage by mass. So it means that I need to determine what is the mass. How to do that? So let's go back to the page again. I said that in order to convert mole to the mass, I need to use this equation. So mass is equal to molecular weight multiplied by moles. Hopefully it's clear. And let's go back here. It's equal to 11 multiplied by molecular weight. So let's write all of them. And the summation will be 2,940. Okay. It will be mole, as I said, the unit. So let's say this is gram over mole. And it means my mass will be also given by gram. Yes. And I got 2,940. Now it's said to find mass compositions. How to do that? Mass compositions by percentage. So I need to take every individual component, like, for example, oxygen over summation, the total amount of this compound. It's equal to oxygen itself, one individual, over the total amount. And this one, okay. It said like the percentage, that's why we should also multiply by 100. It's approximately 12%, as you can see. And drop down. Let's see what is the summation. Yes, it's exactly 100. It means that we have done it correctly. So in the question, it was asked to find the mass compositions. And for example, for oxygen, we have found approximately 12. For CO2, carbon dioxide, we found approximately 9. And nitrogen, it's 79, sorry. And the full amount will be 100. It means we have done it correctly. That's all. This will be our answer. Now, let's go to the second question. The second question, it's also given in this way. Again, I will draw one table: gas, CH4, methane, hydrogen, nitrogen. I believe how to find the molecular weight, the calculation formula was clear. That's why I'll write directly 16, 2, and 28. And sum here, we don't need this summation of molecular weights. And it's given like, okay, there was one mistake in the question. It should be not mole, it should be mass. In the question, it said you have 100 kilograms of gas of the following composition. It means the basis is chosen and selected again by the question writer. It's like 100 kilograms. So I don't need to like choose one more basis for myself. This is 100. It means I will determine, I will write first of all mass composition, then mass. Mass composition, it's given 30, then 10, then 60, and sum will be 100 most probably, yes. And let's find the mass, the total amount of the gas, let's say the gas compounds, all of them, multiplied by the mass percentage over 100 because we need to use the fractional conversion here. Okay, and this. This is kilogram because in the question it was given also kilogram. Next, we need to find out what is the mole. So moles will be equal to, again, let's go to the paint again. In order to convert the moles to mass, mass to moles, mole is equal to mass over molecular weight. And I will apply the same theory, 30 over 16. And drop down. Let's find the summation. Yes, we got in total 9.01. This is kilomole. And molecular weight will be kilogram per kilomole. Okay, so we have found all of the things that's asked in the question. What is the average molecular weight of this gas? So to find average molecular weight in VW average, so we have an equation like the total amount of, let's write gas compounds over, this is mass, I'll write in red, and then total amount of gas compounds this is mass over mole. We have also another like equation, but I will use this one directly. It means I will find my MW average equal to total mass 100 kilogram, it was given, over 9.01 or 02. It will be total amount of the moles or gas compounds. It will give me 11.09 kilogram per kilomole. Hopefully it's clear. And it's not asked to find like mole compositions, but if you wanted to do that, so you need to take individual over the total amount of the gas compounds and multiply by 100% because it's percentage, and you will find each of them. Let's write it also. Okay. Okay, let's see if it's 100. Yes, this is correct. It means we are on the correct like direction. That's all for today. In the next class, we'll also discuss some another additional like material for mass and energy balances, like starting point, and then we'll also delve into the very practical and very complicated mass and energy balance problems. That's all. See you in the next video.